My guest today is Ib Green, who's led the development of 3D visualization tool like Uber's deck.gl and is now working at Foursquare. I know relatively little about what it takes to display a lot of data fast in the browser, but also recognize that it's becoming a bigger and bigger thing. So I wanted to take this conversation as an opportunity to ask Ib, who knows a lot more about it than I do, about what it takes. We also talk about open governance, something that I hadn't thought about before, which is not just having an open source project, but also having it owned and directed by an open community, and why a private company, in this case Uber, might want to do something like that. On this podcast to a minimum and as relevant as possible. Most episodes only have one sponsor segment, and a part of that is because of people supporting this podcast on Patreon. If you've listened to this before, you've heard me talk about business models and how people should make money. And turns out that most company putting things on the internet are funded through advertisement. I deeply believe that there are better ways to fund things on the internet, and this is why if you found any value from these conversations, not necessarily agreed with me, just gotten value out of them, I would really like to ask if you could consider supporting this and all the work that I do here on Patreon. I also post some behind the scenes about how this podcast is made, as well as some of the explainer video that I've been doing around satellite images lately. So you can find a lot of great stuff there. Either way, thank you for listening, for your support, and here's my conversation with Ib Green. I don't know if you know, I like starting these conversation the same way every single time. I like asking people how they would describe themselves. I'm quite curious, how would you describe yourself?
I think I'm curious, and I think I like building things, and you know, I love software, and so these things come together, and I like something to be. I like to work on something that's intellectually stimulating, and so I think those would be some of my characteristics. I love collaborating, especially in small groups with passionate people, and those are some of my characteristics.
I would like to together to go on a bit of a journey on some of the work that you've been doing. So like, to get into that and to visualizing what that looks like today and the geospatial aspect in the browser. I want to get into all of that. But when I was doing my research, I realized that's not where you started your career, if I understood correctly. I think you started working for quite a while on mobile development, actually, like before the whole smartphone era. And I think in a previous interview you said like you had to pivot quite hard into the work that you've been doing. And so the reason I ask this is because I'm always curious to know how people end up working in what they are. And so I'm quite curious how you ended up working on what you are today, having had to go through quite a pivot in your career. Like, what led you? What did you find interesting in some of the work that you're doing today to change your career towards that?
Yeah, it's a good question. I got my first computer in 1982, so it's you know I've been doing this for 4 decades, and obviously the industry has changed, very very dramatically, and so I think it's unavoidable that one would need to do a pivot or two in that time to remain relevant. Um, I mean, as you start out with the passion of software and building things, and then there's obviously the reality of a career. And I went through all of those steps. I started out in computer aided software engineering, building tools for other engineers back in the 1990s, and then the mobile industry became very big, and I lived in Sweden at the time, and Ericsson was building a huge, basically software development organization for its mobile phones, and I think most anyone who was good at software ended up in that organization, and that was quite an international operation, and it took me through 4 different countries. I worked in in Europe, in the United States, in Japan, and in China in that decade, and had a kind of an international management career. And then I ended up in Silicon Valley at the end of all of that. And then the iPhone came along and disrupted the traditional phone manufacturers. And so there was quite a big shake-up, and it was obvious that that industry was becoming more and more of an integration industry and less of a industry that, would be satisfying for someone who wanted to build and create new things. So then I started, talking to different companies in Silicon Valley, and ended up working for some of the big companies like VMware, for instance, for a couple of years, and had a great experience there. Um, but I was kind of a manager, a middle manager in those at that time, and I wanted to go back to engineering, and so ultimately I joined a small startup and um, focused on visualization and GPU programming and so on, and that eventually led me to I got in touch with Uber, who was in their hypergrowth phase in the fairly early stage, and they were interested in using the kind of technologies that I was using, GPU programming, WebGL, to visualize the big amounts of geospatial data they had. And so they had just a very kind of loose idea, a vision of what could be built, and that sounded wonderful. So that I joined Uber and started, and really, if in terms of a pivot, I had to kind of learn, web programming from scratch. I came from more of a C++ type background, and obviously, web GPU and the entire tool chain. And then as we kind of pushed into geospatial, then all the different geospatial data formats and the techniques and the projections and coordinate systems and other things. So um, and I think to me it's just the right level of of mental kind of challenge. You have the 3D math aspects of it, you have the GPU aspects of it, and then you have this added flavor or spice from the non-linear coordinate systems that you have to deal with in geospatial. And so um, I think I got really really hooked.
You joined Uber around 2015, if I recall correctly. What does that look like? What is the work that you're doing at that time look like? Why is Uber looking for visualization tools? Can you kind of take me back, now nearly a decade? What does the landscape look like, both in terms of the technology, the problems that these companies, I'm sure there's others than Uber, are trying to solve at the moment that you get brought in and then you're learning about all of these techs?
Yeah, so if you think about Uber, one way to maybe think about it, it's a planetary scale transportation machine. And so, the amount of trips that are being done every day on a global level is, mind-boggling. And the amount of data that's being collected on every trip, all the pings, the GPS pings, and so on, and other information is, in the order of many megabytes. And so, all this data flows through, an incredibly sophisticated data infrastructure. And ultimately, as you build up, and in a company that at that time was just focused on expansion and hyper growth, eventually to reach profitability, what you want to do is, once you've built the scale that you uh, that you wanted, now you have to work on efficiency. And the understanding then is, because of the sheer scale of the operations, if you can do even like a 0.01% improvement in efficiency in those operations, you probably paid your salary for a couple of years, right? And so the company was really looking for any edge, any tools to kind of just eke out extra efficiency, from the operations. And so there were many operators, thousands of operators, that were trying to make sense of the data. There were data scientists, but also, more kind of manual operators. And these operators, would be more productive if they had good tooling. And so the tooling would be able to surface the various patterns in the data. And obviously all that data was geospatial. And so, geospatial data has, is different from other types of data in the sense that there is a limit typically to how much you can, you know, how you how much data you can visualize if it's not geospatial data, right? Like if you put 1 million points on a chart, it's just going to look like on a screen, it's just going to look like a blur. You can't really make sense of it, right? You have to group it and aggregate it. But with geospatial data, because our brains understand what it is, it has geospatial extents on a map. You really are much less limited in the amount of data that you can show, and so the visualization techniques that we wanted to explore, that were optimized for the geospatial nature of Uber's data.
So you were building internal tools, if I understand correctly, to help the
Yes,
teams that are then trying to find patterns and optimize the internal flows.
yes, we were building. We were working kind of in an internal consultancy model. So we were building frameworks and techniques and very, very deep skills in data visualization and to some extent analytics. And then we kind of joined on a time limited basis other teams to help them build up tools on these frameworks. And so it was quite a powerful setup because you the frameworks were created from the need of real tools that were we were solving real problems, visualizing. It started out with the marketplace, and the marketplace, it's basically where you balance the demand and the supply. So you have a certain number of drivers, and there is a certain place in the city, and you have a certain amount of riders, and they are in often different places in the city. And how do you and when these are not in balance, if you have you know too many drivers, then it's obviously waste. If you have too few drivers, then you get surge and other things problematic, increased prices or increased waiting times. And so at that time we thought about those conditions like an inflammation in the system, and so we wanted to create tools that could visualize what was going on and make the operators understand where the imbalances came from, and explore over time if you did various types of campaigns, maybe you could add features to the driver application that indicated where they should be going next, to make sure that they were closer to the riders. There could be various types of campaigns where you gave additional financial incentives to the drivers, or there could be campaigns that reduce the prices for the riders. And what you wanted to do is you wanted to be able to compare, week by week, right? Like what happened a Friday evening 1 week ago or 1 month ago when we didn't have these, you know, uh, conditions, and so that you could really, um, you know, validate what the effect of the various actions that you took to improve the marketplace were. And that was the first of many tools that were built. I think in the end, there was some kind of survey being done, and I think there was almost 4 dozen applications, internal operations applications in Uber built on this technology stack. So it ended up being quite successful.
And some of these end up being open source down the line, right?
So the in, yes, so we very early on open sourced the framework stack, and a little bit later we open sourced the kind of most. So one of these tools was very generic. It was we called it Kepler GL, and it was basically a tool for that wasn't tied to Uber's business in any specific way, but just a tool for exploratory, visualization and exploratory analysis of geospatial data. And that tool we also open sourced.
What's the rationale behind that? Like in that whole process? So w- you're developing tools internally to solve very specific problems, and then on the side you're putting some of these, core frameworks out as well. Usually there's a few reasons why companies might do that. It's a way to attract people. It's a way to kind of make a name for yourself as well on the technical side beyond just the core problem that the company is solving. What is some of the internal discussions behind some of those decisions? What does that look like? Was it from day one? Did it happen later on, realizing, hey, we have this pretty cool tool, we could put it out there, other people might have the same problem?
I think that there's um, there was a very strong wish from myself and the engineers that were working on this to work in the open source model. So we felt that that was the superior model to develop code, and developing it, if it doesn't include, proprietary components, anything that's, you know, um, would reduce the competitiveness of us as a business, then I think I personally think that, it's better to develop code in the open. And obviously, it takes a little bit of extra dedication from engineers, because the code needs to be, cleaner and a little bit more general, and you're going to have to do a little bit of interaction with the community. But you're also going to end up with a code base that is stronger, more solid, more well documented, more vetted, and more long lived, more that will endure, most likely longer than it would be if it was internal. And I think so we were pushing for the open sourcing, and I think generally at that time it aligned pretty well with the values of the company, because tech brand was something we wanted to develop, and it was kind of generally recognized that by maybe some extent accident, or by the kind of forces that of being such a hyper growth company, we had attracted an incredibly strong visualization team in Uber, and so it made some sense that there would be something coming back from that visualization team to the software community. And so um, I think that's so I think getting these frameworks and Kepler-GL open sourced was, in some sense, in retrospect, a smaller step. I think the bigger step perhaps was taking them then to open governance, not only open source, but actually making them open governance. And there was a little bit more discussion, and maybe some inertia, if not resistance, at least some inertia in that case.
What does that mean? And
You can look at it in different ways, but as a company, if you have some open source project out there, then you are still in some way the owner of that open source. You can, for instance, decide that the next version of that is no longer going to be open source or be under a different license, and you can have the requirements that you have on. There can be small things. It matters not so much to in many cases, but it can be right, like how are the licenses packaged up in the repository, or is there a requirement that you sign a contributor license agreement before you can make a commit? And those things can really push off some big companies, let's say Google or Apple and so on, may not want to may want to be part of this, but may hesitate because the governance is not open. They cannot control those aspects, some kind of legal aspects, or some kind of practical aspects. So that's one side to it. But it's also the guarantee that if it's under open governance, it is going to stay open, and there it is. Even obviously not everyone gets to influence you know things from day zero, but at least there is a meritocracy. And if you invest as a company in this framework and you start contributing, then you will get influence over the software in proportion to your contributions. And so um,
so you're handing the reins and the sort of ownership, not just of what gets released today, but what's going to come out in the future of that project. Whereas open source is just like, hey, here's the release, the code is right there, but there's no guarantee that if there's a breaking change in a future release, that is going to also have the same licensing. So it's having sort of longer term vision of the project, if I understand correctly.
Exactly, and also then there is an expectation in an open governance model that you share roadmaps, early on, and so that people can respond to the roadmaps. They don't suddenly just discover that there is a new version 2 out that is massively incompatible and has chosen a different approach.
How do you sell that internally at a company? Oh, I can understand, hey, we're going to put this, open source. We want to have a sort of technical leadership that's seen out there. We want to go to a few conferences and talk about our new cool open source project. This sounds like the next step, and it kind of feels like you are giving up even more as a company. How do you sell that internally to a company and say, hey, all this project that we've developed internally that the company is paid to develop, now we're gonna potentially have someone else come in and own that.
Right. Well, I mean, first of all, the kind of lifeblood of any open source project is the technical leads, the people who really have the technical vision. And so, you know, the more technical leads you can attract to your project, the stronger it is. And if they leave, it's typically, it can be devastating. And so most of the in practice, most of the decisions, most of the, you know, normally open source, taking a project to open governance doesn't, rarely mean that you, lose control on that level. Obviously there's some extreme cases, maybe, some back end software that suddenly is being deployed by Amazon, and, you kind of out competing the original, developers and so on. So there are cases where, the implications could be pretty serious. But if you're thinking about this, you after a while, a number of years, you've developed this software, and the code base becomes quite big. It can become enormous, as it certainly has in our case. And you want to attract more people, and ideally you can attract individual contributors to some extent, but ideally you want companies to buy into it. And so, one of the things that we were able to have been able to achieve with the moving these things to open governance is that we've had other companies in the geospatial industry adopt these frameworks, these technologies, and make them part of their product. And in return, they've put really, really good people on, both maintenance and the continued development of these frameworks. And at some point, the effort of maintaining this may become bigger than one company is comfortable with. And so, if a company is pretty invested in this and they know that they need to maintain it, and the cost, obviously, of switching away from this project to another project would, in almost all cases, be very, very considerable. It can actually make a lot of financial sense to go for an open governance model.
So you spend a few years at Uber, and then you start your own company with three other people. You go on in 2019. You start Unfolded. Can you talk to me a little bit about what you were doing there, what the company was doing, and what the rationale was for going ahead and starting a company?
Yeah, I think the part of the rationale was that during its hypergrowth phase, Uber had been an incredible place to build up these technologies. But Uber was maturing as a company, and the focus was shifted very heavily to achieving profitability, and of course, very very important goal. But what we the people who ultimately went on and founded Unfolded felt was that this technology stack, we really had just started scratching the surface. There was so much more we could offer, and we saw that there was a very big usage of this technology. We had some, analytics on Kepler GL, and we could see that there was, you know, by some measure, 50,000 monthly users on Kepler GL. And so, it seemed to us that we all wanted to continue to develop this technology. We felt that we could offer more, we could help more people with it. Even as, feeling that Uber would also, with all the tools that they had, built on this, would benefit from this continuing to be, you know, um, invested in to, a significantly bigger degree than Uber was, seemed to indicate that they were willing to do. And so I think that was, one trigger. Um, and I think we were all kind of ready to see if we could, if by focusing we could really build a useful geospatial tools for a bigger industry. Um, it felt like, you know the tools that were open source. I mean, Kepler GL, deck.gl, it needs, you need to be a programmer to use it. Kepler, you has a, point and click user interface, but still it doesn't have a backend. Everything's uploaded in the client. But if you want to save your work and come back to it and share things and so on, you can do it, but in kind of a clunky way. And so, since we had a lot of users, it stood to reason that some of those users might want a little bit more. And so, if we could add more capabilities, um, you know, that might be useful.
I have this sort of fascination with business models and how companies fund everything that they're doing. What was the core value proposition of Unfolded? Was it a little bit like something like a black hat? So you provide support for, sorry, red hat. Um, Support for the open source project in a more enterprise way? Like, was that the way that the company was going around? Were you providing additional features? Yeah, how were you putting food on the table, basically?
Yeah. So, I mean, there was a couple in the initial pitch decks. There was a couple of different, proposals. I think there was like included like a little data marketplace, and I think in the early days we did some open source consulting and so on to, as you say, put food on the table. But the main business model was really that it would be a freemium product. And so, you could go from Kepler and realize you wanted more. And then basically the next step you had to do would be to sign up for an Unfolded account. And now you would have Kepler plus, a range of additional feature plus a backend integration where you could, which automatically saved your data, where you could, create projects and also increasingly add capabilities like, you know, um, uploading data, converting data to different formats, tiling data, and so on. Right? There's a lot of things you can do when you have a backend, and so and then as you some of those features would then be pro features. And so you would kind of sign up, be able to use more than Kepler, like a Kepler plus plus, and then if you wanted even more capabilities, then you could, get on a paid plan. So
I want to nerd out a little bit more on the technical aspect, um, but I want to try to stay in relatively layman terms. And the main reason is honestly, I'm not very familiar with a lot of the just web development side, visualization aspect. I'm a lot more familiar with just processing a lot of data, specifically on the satellite image side. But I want to take this opportunity to kind of go into what does it take to build visualizations today. There's more and more things that are happening in the browser. We have more and more types of just pretty ridiculously powerful devices, be it on the desktop, on the mobile side. So we can do more and more stuff. We can just show more and more things. Be it the amount of data, we can move away from 2D mapping to 3D visualization in the browser. I keep being blown away by the amount of like new projects that are completely in the browser that just keep popping up. Um, and so I want to have like this pretty high level. If you were to explain what does it take to build, really good visualization in the browser today, at a very high level, what does it take and what is required to be able to do that?
The kind of core idea behind this entire technology stack, and that became Kepler and later, Foursquare Studio and so on, is really to take advantage of the power of the GPU in the user's own machine. So traditionally, most analytics has been done in the cloud, and people have built big compute clouds, Google and Microsoft and Amazon, where you can run very big tasks, and those certainly have are not going to be displaced uh, by the browser, but the characteristics of being able to have such powerful GPU on the client, there are things that you really, it's very hard to duplicate with the backend. You get this immediacy where the data can be updated so fast. There is no round trips to the backend, and so if you have the data on the client and you want to change parameters, maybe in a raster visualization to highlight, see if you can kind of bring out nuances by mapping the various bands in the raster image, to colors in different ways. You can do that at 60 frames per second, as opposed to maybe changing a slider, having that go back to the back end, the back compute cloud sending back new images or something like that. And so the experience just becomes so incredibly fluid and intuitive. And for I think the thing that we really kind of latched on to when we were at Uber, when we were in the mobility sector, so to speak, was that maybe traditional GIS system could handle very big data, but they tend to be static. It tends to be like the road network in a city, or the plumbing network, or something like that. Whereas here there were thousands or even millions of vehicles moving you know across maps, and so being able to animate those things in 60 frames per second, to see this, to actually visualize that, is just uh, incredibly compelling. And so I think the animation aspect is one where we've done a lot of work, but I think we still just scratch the surface on what you really can do on the client. So um, and it to make it happen, um, well, you're going to want, because you have millions of points, right? So you have millions of data points, millions of rows in your tables, if you will. And so to be able to do that efficiently, you're going to have to do parallel computing. That's what GPUs do well. And so most of the kind of web frameworks for 3D kind of compute, or think your 3JS or Babylon JS, you know they kind of expose you to the mental model that's traditional for 3D. You have a scene graph, so like this graph of different objects that are rendered on a scene, and every object is one GPU draw call, and it's called attributes. It has its vertices, its positions, its normals, maybe colors, texture maps, and so on. As you think about it in terms of like these 3D geometries. But if you really take one step back and think about what the GPU is, the GPU is a massively parallel table processor. And so, you basically, it's a binary columnar table that you upload to the GPU. And then the GPU can do calculations on hundreds or even thousands of rows in parallel. And so a lot of the work that you have to do in these frameworks is to load data, take the data from whatever format it's in, load it, turn it into this binary columnar format that fits with the constraints of the GPU. And then what we do is we basically, for each row, we render some kind of element, whether it's a circle or a line, or obviously we have wide variety of different types of layers that can render different things like hexagons and so on. But the basic principle is that you upload your tabular, your columnar tabular data directly into the GPU, and then process it and visualize it. I like to think of it as a slightly different viewpoint, taking a slightly different viewpoint on what the GPU is, and then that's like the kind of core idea that these frameworks have been just kept building and building and building on. And
This is all happening on the client side. So basically offloaded some of that work onto the client side. But the question, maybe as a naive one that I have, is now you have completely given up the control over like what the hardware is going to be. So you don't know what someone is going to have if they have a 10-year-old laptop or they have the latest iPhone. How do you deal with that wide range of hardware that you can have on the client side, especially because GPUs are relatively expensive pieces of hardware, even entry level ones, compared to like every other type of computer hardware. Like they tend to be on the more expensive side. So do you have to make assumptions? Do you have to have fallback options? I'm really curious about how you handle that.
yeah, there's a couple of different dimensions to it. A lot of the kind of detailed differences between APIs and so on. It's papered over by the kind of the web standards like WebGL and WebGPU. So um, mostly um, mostly we don't have to worry about like those minute differences. The really big differences, you know, the most obvious differences are between mobile devices and desktop devices, and it's not so much, at least on the last few years, on the performance of the GPUs. The latest iPhone and Android devices have really really impressive GPU performance. It's about memory, and so you have 16 or 32 or even 64 gigabytes in a desktop, in the latest desktops, and maybe virtual memory on top of that. So um, but on a phone you only have a few gigabytes, and what the browsers tend to do is they tend to pretty much terminate any tab in the browser, in a mobile browser that grows beyond a certain size, say 100 megabyte or 200 megabyte. And 100 megabyte is nothing when you deal with geospatial data. So it's easy to kind of build an application on desktop, and then you want to deploy it on mobile, and then you discover that the application just gets shut down, right? So I mean, you're going to have a little bit less performant rendering, and loading the data is probably going to be slower because you're doing it, if you're doing it over the air. But I think that's the biggest problem, and you know, we have not, I would say, we've been focused on analysts and data scientists, and so the sweet spot for us is a well-equipped desktop. We have made certain accommodations for mobile devices. So something that can take a lot of memory is creating like a memory buffer of the size of the screen, which we might use for picking operations or something like that. And so if we detect we're on a mobile device, we avoid doing that, or we create one of much lower resolution or something like that to maybe save a couple of 10 or 20 megabyte, and which can make a big difference if the limit for your application is 100 megabytes before it gets terminated.
So RAM memory is much more of a bottleneck than GPU performance and availability in the browser. That's so interesting. I never would have really thought about that.
It's at least it's the immediate problem that you're going to face, right? And if you
Okay. And so do you have like you're saying like you're tailored to more the higher end analyst, data scientist. Do you have kind of this? expectation that there's going to be a trickle down effect, that like whatever you're doing today is going to be just trivial on a mobile phone in like 5 years, or you're not really even thinking about that?
Well, I mean, to some extent, yes, by default, right? Like the mobile phones' capabilities are going to continue to grow and catch up. Uh, but ultimately, if you have an ecosystem like this, people are going to work on the things that, either inspire them, right? If they're kind of individual contributors, which to some extent I am. I work on these things because I'm passionate about them. So every now and then I will, build some feature just because I think that would be really cool to add. But also, of course, what the companies need, right? So the companies that use this, and the companies that most actively are using this right now is Foursquare, Carto, Esri is investing quite big in some parts of the loader ecosystem. Um, so at least the companies there's a lot of companies out there that are building things on top of these, but these are the companies that are really investing back. And these companies are going to build the things that their users need. And so, there's nothing that stops us from optimizing for mobile, but there's just, you know, it just really hasn't emerged as a strong enough priority for anyone to step in. But that's the beautiful thing with it being an open governance, right? That someone who wanted to do something, good on mobile could join, the community, could join the steering committee even, and if you have resources there, the existing tech leads would, you know, jump to help you and get you on the right track and all that.
What are some of the features or the developments that you are the most excited for in the next few years, or the direction that you see a lot of these, browser-based geospatial visualizations tools going? Is it, um, you know, just increasing the scale, increasing the speed, or do you see like some different features coming up? I'm just thinking like the switch from being able to show just a static tile render in 2D to like we're seeing more and more 3D in the browser. Like, what are you keeping your eye on? What are you excited about in the coming years?
Well, I look a lot at the underlying kind of data flow and how can we, push the limits of how much we can do in these frameworks on this, on the client. And I think, um, you look at if you look at end to end, which is like from the loading of data through the processing of the data, then you load it in on the JavaScript side, you do some processing on the JavaScript side, then you kind of upload it to the GPU, and then you render it on the GPU. And so you look at the overhead there. And so one of the big, developments in the last couple of years is kind of the emergence of really well kind of defined and supported binary columnar data format. Initially, we had Parquet, which is an excellent format, but it's mainly, it's optimized for on-disk storage. So there's a lot of compressions and encodings and so on. But now we have Arrow, which is also a binary columnar format, but optimized for in-memory usage. And so the beauty of these formats now, if you load them, and they're multi-language, they're bindings for C++, Rust, Python, JavaScript, and so on, right? And so you can create these and author them in one language and consume them in another language. And there's libraries for all of these. And the beauty on JavaScript is, once you have binary columnar data, if it conforms to certain restrictions, well, that's exactly what the GPU needs. And so today, when you load something like a GeoJSON, which is a kind of a textual format and extension of JSON that can include geospatial geometries, if you will, and so much geospatial data is done with stored in GeoJSON just because it's convenient. But if you look at the loading of it, first you have this parser that has to go through every character, parse it as a state machine, convert it from text into into an internal memory representation, and then that internal memory representation has to be, which is then consists of a very lots of small objects. It's like it's kind of maps that contain arrays that contain maps that contains arrays and objects and so on. Very very memory intensive or garbage collection intensive. Then needs to be converted into some kind of raw binary columnar format, and then that binary columnar format is uploaded on the onto the GPU. And so there's so much overhead just in the loading, parsing, conversion before you even get to the point where you can you can use it in the GPU. But when you come to something like Arrow or a loader that loads GeoParquet and expands it into binary columnar in memory, then you can more or less send that data directly to the GPU without any further processing. So you can more or less, in the case of something like GeoArrow, you can you can almost memory map the data that comes from the network adapter into the GPU, and so you completely remove. We're not talking about making it 10x faster or like even 100x faster. You make it like infinitely faster because you completely remove that entire software part of the software stack, and so really optimize it to the bone, if you will. So this is something we've been really excited about in the uh, open visualization community that we have, and we've been chipping away at it over the last couple of years, and it's starting to become. The results are out now, and first results, and people are really really impressed, blown away.
And so this is, you're saying like this is done all in the open. This is not just a Foursquare project or work
Absolutely,
like you.
absolutely, yeah. So there's I think there's now GeoArrow support in Kepler-GL 3.0. There's a ton of work done by myself and others in Loaders.gl to create like loaders for all these new formats and to convert data into binary, and especially the work that's also that another member community, Kyle Barron, is doing on Lonboard,
Mm-hmm.
where he's been able to take, because he's focusing very much on just this particular use case, and maybe not kind of dragged down by the weight of the big frameworks, been able to move, really fast, and I think that shows he's really been able to show, how performant this is, when it's fully executed, and I think he's getting a lot of well-deserved attention.
I funnily enough, I was just thinking about Kyle as I was hearing you talk about this. I was wondering, I'm not as familiar with that side of the work, but I've been following a little bit. It's nice to hear that name. This does feel like a nice place to start rounding that our conversation off. Just like how I start the conversation with the same question, I like ending them the same way as well. I like asking for a book or a podcast recommendation. There's a couple reasons for that. First, I think a lot of the new books and podcasts I hear about, most of them is just through word of mouth. I think they're still in this place of mostly just people talking about, hey, I read this cool thing, you should too. And I think it's just a nice way to get to know people a little bit more and their interests. So it doesn't have to be about anything that we discussed today, but just if you read, if you listen to podcasts, if there's anything that you've come across recently that you think might be worth sharing, just for people listening, for them to check out.
I don't I, I don't follow a lot of podcasts, to be honest. I get, I guess, my information more organically, in
Hmm.
that sense. So I'm ashamed to say. And in terms of books, I'm a little bit strange. I read math books for my entertainment, and so it's
Do you have any good ones? Anything that you've come across recently that particularly piqued your interest?
yeah, I have this interest for something called algebraic geometry, but it's it's, I guess it's an acquired taste. It's not something I'd recommend given the amount of preliminaries that are involved. But I do like, yeah. There's actually, there's something called there's a couple of these really big problems, in mathematics, like the Riemann hypothesis and the Langlands program, and the correspondence between different areas of mathematics that I find incredibly fascinating. And there's a series on YouTube that's called Peak Math that describes and digs into these things, and I found that to be incredibly well done and interesting. And so it kind of, seeing the cutting edge of the research in mathematics explained in a way that you can understand and really kind of get excited about. So
Yeah, that sounds good. I haven't heard about that. I'm gonna go check that out. Yep, thank you very much for your time. Thanks for the conversation. This was great. Hey, thank you so much for listening to this conversation. I wanted to take a moment to thank the sponsor of this video, but also all the people who financially support me on Patreon. If everything goes well, these conversations should feel and sound seamless and effortless, but there's a lot of work that goes behind the scenes. I try to research and prepare these as much as I can to know who these people are and what makes them interesting and what would lead to a good conversation. I'm incredibly thankful to all the people who support my work on Patreon, meaning I can do a little bit more of it. This podcast started out as a way to learn more about the people in this industry, but I've also started making educational content on another YouTube channel that I'll put a link to in the show notes. And I want to make more content explaining how satellite images and maps work to a broader audience, as well as continuing to research the guests for these podcast episodes. So, if you value the work that I do, I'd like to ask you to please consider supporting my work on Patreon. There's also some behind the scenes of how this podcast is done and some of the work that I'm doing for these educational videos if you want to learn more about how I do all of this. Either way, thank you so much for all of your attention and your time. I really appreciate it, and I hope you get value from these conversations. Thanks.